Welcome to Honors Geometry 7.2 Converse of the Pythagorean Theorem. Okay, the Pythagorean Theorem says that in any right triangle, starts off with a right triangle, then you can say c squared equals a squared plus b squared. Converse, obviously going to say, if c squared equals a squared plus b squared, then it must be a right triangle. So let's go ahead and see what it says in words. Here we go. I'll let you go ahead and write that down, and then I'll give you some examples. Alright? I don't know. Did I give you enough time to pause? Well, if I didn't, you can pause again. Here go the examples. Determine if the three lengths form the sides of a right triangle. 4.5, 6, and 7.5. So what you're going to do is you're going to find the longest side, which is 7.5, and go 7.5 squared. Compare that with 4.5 squared and added to 6 squared. Alright, this would be 56.25 compared with 20.25 plus 36. Hey, those are equal. This is a right triangle. 7, 7, and 7. 7 squared compared with 7 squared plus 7 squared. It's pretty obvious to see that 49 is not equal to 98. This is not a right triangle. Of course it isn't. It's equilateral. You should have seen that off the get-go. I hope you did. I'm sure you did. Okay? 8 radical 3, and 16. First of all, you got to find out how long 8 radical 3 is. So take 8, multiply it times radical 3 on your calculator. You'll see that it is less than 16. But go ahead and do it anyway. It's less than 16, so 16 is the biggest one. 16 squared compared with 8 squared plus 8 radical 3 squared. 16 squared is 256. 8 squared is 64. 8 radical 3 squared. I'm going to go up over here. That means 8 radical 3 times 8 radical 3. So you've got the 8 times the 8, which is 64. And you got root 3 times root 3. Yes, that's right, 3. So 3 times 64 is 192. And when you add those together, you get 256 equals 256 equals, hey, it's a right triangle. And that's how you use the converse of the Pythagorean theorem. Now there are a couple corollaries that follow the converse, and we'll talk about those right now. These are some corollaries that fit the converse, and I'll let you go ahead and write those down. And this is why we wanted c squared equals a squared plus b squared. Look what you got here. With this greater than symbol, okay, what's greater than 90 degrees? Obtuse. What's equal to 90 degrees? Right. What's less than 90 degrees? Acute. So when we set it up this way, it actually helps us remember, and it makes sense that it works that way. So go ahead and write this down, and then I'll come right back to you. Alright, here we go. Let's go with some examples. Determine what kind of triangle, if any, can be made from the given sides. 1, 2, and 3. Wait a minute. 1 plus 2 is 3. 3 equals 3. This is not even a triangle. The reason it's not a triangle is because the two small sides have to add up to more than the third side. So you better pay attention to that. Okay, 4 plus 4 is more than 5, so it is a triangle of some kind. Let's find out what it is. Okay, let's take the biggest side. Okay, 5 squared compared with 4 squared plus 4 squared. 25 compared with 32. That's less than. That would be an acute triangle. See what we're doing here? I hope so. Alright. 21, 10, and 14. 10 plus 14 is 24. That's more than 21, so you can make a triangle. Let's find out what kind. 21 squared, that's the biggest side, compared with 10 squared plus 14 squared. So that would be 441 compared with 100 plus 196. 441 is greater than 296. This would be an obtuse. Wow. Might help if I spelled it right. This is an obtuse triangle. Okay, 11, 22, 33. 11 plus 22 is 33. It needs to be more. Not a triangle. Okay, 12, 9, 15. 15 is the biggest side. 12 plus 9 is 21. That's greater than 15, so it can make a triangle. So 15 squared compared with 9 squared plus 12 squared. 15 squared is 225 compared with 81 plus 144. Those are equal. That would make this a right triangle. And that's how you use the Pythagorean converse and its little itty-bitty corollaries that follow along. Those corollaries, again, are theorems that follow a theorem right away. And here they are right here. Alright, so this does conclude Honors Geometry 7.2. Converse of the Pythagorean Theorem.